Compound interest can be thought of as interest on interest because it is calculated based on the principal plus any interest that's accrued. It will make a sum grow at a faster rate than simple interest, which is calculated only on the principal amount. Compound interest is a little bit more complicated to calculate than simple interest, but it's more common in real life, and therefore it's important to know how to calculate. In this video, we're going to look at what compound interest is. We'll look at a couple of the variations of the compound interest formulae, and we'll look at a couple of examples. By now, you're probably familiar with what interest is. Remember, interest is the amount paid to an investor by a financial institution for investing money with them. It is also the amount paid by a borrower to a lender for money lent to them. Interest is calculated as a percentage of the amount invested or borrowed. In this video, we'll look at the method for calculating compound interest. Compound interest is far more common in finance and banking than simple interest. Compound interest is a method of calculating interest in which the interest is added to the principal each period. Interest is then calculated on the new amount. In other words, interest is earned on the interest. Majority of investments and borrowings earn or incur compound interest. If you have money in a standard savings account, the bank will be paying you compound interest. There is more information, including a discussion of the key terminology, in my investing and borrowing introduction video. Here's a graphical representation of the value of an investment over time, comparing simple interest with compound interest. You'll notice that simple interest grows linearly, while compound interest grows exponentially. To show the compounding effect, we can repeat the simple interest formula on the closing balance of an investment each year. What is the total amount of money in an account where $5,000 is invested at an interest rate of 5% compounded annually after 3 years? The principal is $5,000, the rate is 5% per annum, and the term is 3 years. We start with $5,000 principal. Using the simple interest formula, $250 is earned in the first year. To find the closing balance, we add the interest to our principal, and we get the closing balance is $5,250 in the first year. This becomes our opening balance in the second year. Again, we repeat the simple interest formula on the opening principal in the second year. This year we get interest earned of $263. We add that to our opening principal, and we get the closing principal, which becomes the opening balance in the third year, of $5,513. This becomes our opening principal, and we perform the simple interest formula on it again. And this year we get interest earned of $276. We add this to our opening principal, and we get the closing balance of the investment after 3 years is $5,788. The total interest earned is $250 plus $263 plus $276, and over the 3-year period, a total of $789 was earned. Consider $5,000 invested at an interest rate of 5% per annum compounded annually for 3 years. Let FV be the future value and N be the number of years. The $5,000 is increased by 5% at the end of the first year when N equals 1. To increase 5,000 by 5%, we multiply it by 1.05. After 1 year, we have $5,250. In the second year, the new value is increased by a further 5%. This is the same as writing 5,000 times 1.05 times 1.05. This can be simplified to 5,000 times 1.05 to the power of 2. After 2 years, there would be $5,512.50 in the investment. In the third year, the new value is increased by a further 5%. This is the same as writing 5,000 times 1.05 times 1.05 times 1.05. Simplifies to 5,000 times 1.05 to the power of 3. And in the third year, the future value of the investment is $5,788.13. From this pattern, we can see that the future value of the bank account after n years is 5,000 times 1.05 to the power of n. Here is a graphical representation of the future value of the investment after n years. We expect that the bank account will grow in a smooth curve rather than a discrete jumps. We therefore expect it will be given by the exponential function 5,000 times 1.05 to the power of n. You'll notice the function is increasing or growing. Similar to simple interest, different texts use different formulae and paranumerals for the compound interest formula, but you'll still get the same answer as long as you know how to use each one. I've included a couple of common formulae here. A and FV refer to the final amount or final value or future value of an investment. This is what we are calculating when we're using this formula. P or PV both stand for the amount of money borrowed or invested. This is known as the present value or the principal. Exactly the same as the simple interest formulae. The main difference is that the formula on the left includes the conversion of the percentage interest rate to a decimal in the formula, R on 100. The formula on the right assumes you've already done this and you're including the interest rate as a decimal in the formula. N represents the same thing, time, usually in years. And that's it. Whatever formula you use is up to you. I'll show you examples on how to use both. The main difference between the simple interest formula and the compound interest formula is that the simple interest formula calculates the interest, whereas the compound interest formula calculates the future value or final value, including the interest. That means there is an extra step to find out the amount of interest paid or earned. To do this, we take away the principal from the final or future value. Let's look at an example. Will has $14,000 to invest. He invests the money at 9% per annum for 5 years with interest compounded annually. How much will the investment grow? How much interest will he earn? We'll use the formula that converts the interest rate to a decimal. We're finding what the investment will grow to, which is A. The principal is $14,000. The rate, the interest rate is 9%. N on the time is 5 years. We substitute those values into our formula and we calculate and we find that the investment will grow to $21,540.74. Now we need to work out how much interest is earned. To do that, we take away the principal from the final value and we can calculate it to be $7,540.74 interest earned. Let's look at another example. How much would Roger have to invest now to have $5,497.77 in 3 years at 6.2% per annum? This time we're trying to find out what he would need to invest. So we're trying to find out what P or principal is. We know he's trying to have a final value of $5,497.77. This could be for any number of reasons. Maybe he needs to purchase something that amount. The rate is 6.2%, time is 3 years. And we're going to use the formula where we convert the rate to a decimal within the formula. We substitute those values into our formula and we can simplify it to $5,497.77 equals P times 1.062 to the power of 3. Then we divide both sides by 1.062 to the power of 3. We put that into our calculator and we work out that the original principal that he would need to invest is $4,590. Let's look at an example using the other formula. Robert invests $2,500 at 5% per annum for 4 years. What's the future value of the investment? How much interest will Robert earn? We're trying to find the future value. The present value is $2,500. Interest rate 5%. Converted to a decimal is 5 divided by 100 is 0.05. Time is 4 years. The compound interest formula, we substitute our values in. When we calculate, we get the future value is $3,038.77. But how much interest was earned? We need to take away the present value from the future value. We substitute our values in and we find the interest earned was $538.77. In summary, there are a couple of different formulae that you can use. Whichever one you choose, make sure you know how to use it and you won't have any issues. Thank you.